Good morning. This is Dr. Yogesh Agrawal, Associate Professor, Sagar Institute of Research and Technology, Bhopal. Today I will discuss the topic work input for the single stage compression process and the effect of the clearance volume for the work of compression. Before going on the main slide, today I will discuss about the outline. This is the outline of the today lecture: air compressor, reciprocating compressor working, reciprocating compressor equation for the work done with the clearance volume. This is the first slide. What is the compressor? Already discussed in the previous class, but today I will discuss also about the compressor, a device which takes a definite quantity of the fluid, usually of the gas and the most often of the air, and deliver it a required pressure. This is the main functioning of the compressor, and the air compressor sequence of the operation takes in atmospheric air, compress it, and the deliver it to the storage vessel. That is called a reservoir. Compression require the work to be done on the gas. It is called a power absorbing device, and they're taking the work from the outside, and the work is done on the it, and it is called a negative work done. Compression must be driven by the some sort of the prime mover, just like an engine. This is the principle of operation, where the figure it is depicting the functioning of the compressor single acting piston, which is the action in the cylinder of a reciprocating compressor. The piston is driven by a crankshaft by a connecting rod. At the top of the cylinder are of a suction valve and the discharge valve. There are the depicted in the figure from the either side. This is a suction valve and this is called a discharge valve. A reciprocating compressor usually has the 2, 3, 4 or the 6 cylinder in it, depending on the application. This is the equation for the work for the different compression process. First is the isothermal process, which are the depicted in the inside. This is the isothermal process 1 to 2 dash. This is the PV is equal to C. PV to power gamma is equal to C. It is the outermost line, and the PV to power N is equal to C, which is the called practical line, which is the depicted in the figure. This is the power. PV power N is equal to C, where the N is called a polytropic index. So 1 to 2, that is called the polytropic compression. 2 to 3 is the delivering of the air, and the another process is the remaining 0 because of the considering the clearance volume is 0. Operation 4 to 1, that is the volume V1 of the air, which is aspirated into the compressor at the P1 and the T1. 1 to 2, that is the air compressed according to the polytropically law. PV to power N is equal to constant from P1 to P2. Temperature increases from the T1 to T2. 2 to 3, that is the compressed air at the P2 and the V2 with the temperature, and which is the rise of the pressure. This is the deliver at the temperature of T2. During the compression, due to the excess temperature above the surrounding, there will be exchange the heat to the surroundings. Compression index N, which is always less than the gamma, the adiabatic index, as the compressor is a work consuming the device. That is the every effort it is the make desire to the reduce the work. Work done is equal to area under the PV curve. 1 to double dash, that is the adiabatic compression, that is called a maximum work. 1 to 2 is the polytropic compression. 1 to 2 dash, that is the isothermal compression, that is called a minimum compression or the minimum work done required. This is the diagram where the isothermal efficiency, which is the depicted in this diagram also, because of the isothermal having of the requiring the minimum work done or the actual work done, which is the important, it is already considered the actual work done, that is depending on the type of the condition. This is the isothermal efficiency is describing in this figure. This is the PV diagram, and the isothermal work and the actual work, it is a total ratio. It is called the isothermal efficiency. Thus, more the isothermal efficiency, more the actual compression approaches the isothermal compression work, or the this is the actual work done, which is describing here 4, 1, 2, 3, 4 in the diagram. This is the 4, 1, 2, 3, 4. That is called the actual work done, which is the describing here. This is called a polytropic work done. Actual work done, that is the area 4, 1 minus of the area 1, 2 minus of the area 2, 3. So area 4, 1, that is called a P1, V1, and the area 1 to 2, that is the compression work done by the polytropically law. P2 V2 minus of the P1 V1 upon n minus 1 minus of area to 3A, that is the delivering section. So this is the constant pressure process P2 V2, and the P1 V1 minus of the P2 V2 is taking as the common minus of P2 V2 minus of P1 V1 upon n minus 1 P1 V1 minus of P2 V2 plus of, can you write this, P1 V1 minus of the P2 V2 upon n minus 1. So when the writing of this is taking place in the compressor slides, then the procedure for the compression work done, which will be different and represented in the next slide. So this is the total functioning of the how to calculate of the work done in the reciprocating air compressor. So isothermal work done, it is represented in the diagram 1 plus 1 upon n minus 1, and the here the bracket P1 V1 minus of the P2 V2, n upon n minus 1 P1 V1 minus of the P2 V2, n upon n minus 1 P1 V1 1 minus of P2 V2 upon P1 minus of P2 V2 upon P1 V1. Similarly, we know that P to power n is equal to C. It can be writing as P1 V1 power n is equal to P2 V2 power n. We know that when the relationship is here represented this form, can you write this V2 by V1 is equal to P1 by P2 to power n minus 1 minus n. Putting these values V2 by V1 in these equations, so that's why the isothermal work done will be changes from n upon n minus 1 P1 V1 already in the equation, but it can be changed in the inside. So this is the changes value in this form is represented in the equation form. Then the ultimately from the diagram and the equation, it can be represented on this form. So after all, it will be obtained n upon n minus 1 P1 V1 in the bracket of 1 minus V2 upon P1 to the power of n minus 1 by n. In the isothermal work done, that is the n upon n minus 1 MRT1 in the bracket of the 1 minus of the P2 by P1 n minus 1 by n. And the T2 for the delivering temperature calculation, it is required, that is a T2 is equal to T1 to the P2 by P1 to the power of n minus 1 by n. This is the main equation for the delivering temperature calculation purpose. So this is the equation for the work when the clearance volume is taking as the 0. And when the clearance volume is considered, then the work done formula will be changed. The clearance volume is expressed as the some percentage of the piston displacement. Air in the clearance space will expand during some part of the outward strokes of the piston, that is called the expansion stroke 3 to 4. This expansion continues till the pressure P1 in the engine cylinder, which is sufficient to force open the inlet valve at the 4 point. So this is the diagram where it will be depicted where the clearance space is available. So this is the compression process 1 to 2 compression process, which is the describing or already discussed in the earlier class. 2 to 3 is the this is the delivering of the air at the constant pressure, and after that when the clearance space is maintained 3 to 4, this is the expansion of the air. It is taking place in the engine cylinder through the polydropically rule. After that, the air is sucked from the atmosphere during the suction stroke 4 to 1 at a pressure of P1. This is the clearance volume is considered, already discussed in the previous slide. So this is the clearance volume which is the maintained here. We see volume that remains inside the cylinder after the piston reaches the end of the inward stroke, follow the PV to power n is equal to C. Effective stroke volume, it will be changed from V1 to V1 minus of V4. Actual work done, that is the 1, 2, 3, 4. 1, 2, 3, 4. This is the 1, 2 compression process, 2 to 3 is the delivery process, 3 to 4 is the expansion process, and 4 to 1 is the suction and the constant pressure process is the taking place. So this is the actual work done, which is the held on the compressor sides. The clearance volume, which is the maintained, it is called the VC or the V3, and the effective shift volume, that is called the V1 minus of the V4. The shift volume, that is called the V1 minus of V3, that is called the Vs swift volume, and the total volume that is called the Vc plus of the Vs. This is the equation for the work. The actual work done, which is the describing, is here. N upon n minus 1 P1 V1 minus of V4 for the effective swift volume in the bracket of the 1 minus of the P2 upon P1 into the P1 upon P to the power of 1 by n. So this is the equation which is the deriving from the earlier equations, which are the describing because of the, and this is the equation for the P1 V1 for the inlet condition, and this is the where the entering of the air at the this condition. This is the minus of the taking place. The pressure P4 is equal to P1 and the pressure P3 is equal to P2. Then the actual work done can be calculated from this formula. So this is the condition for the when the clearance volume is considered, and the clearance volume is considered, that will be changes the work done formula, but it does not more effect on the work done for the compressor sides. So this is the today lecture. Thank you. Tomorrow I will discuss about the multi-stage compression.